So part two, just to break it up a little bit, as that video is already at 15 minutes, we're looking at the elk population in a state forest growing exponentially. The first thing we need to find is this growth factor. So as we did with the rock in the last video, we're going to do with the elk population. We have to figure out what are we multiplying by every single time. And we're going to do that by doing the opposite of multiplication, which is division. And I'm going to check it multiple times just to make sure that it is constant. So 743, the last number in my table, divided by the number before it, is 1.9. 391 divided by the number before it is 1.9. 206. All right, 206, not 260. 206 divided by 108 is in fact 1.9. And if I continued this pattern of division, you will see that within one decimal or two decimal places, you'll get 1.9. And the reason sometimes you may get 1.89 or 1.901 is the fact that elk population is not going to be fractional. So the populations are all going to be whole numbers. So when you divide, you're going to get an approximation to within the thousandths place. So our growth factor is 1.9. Again, it's growth because the population is increasing over time. So if this pattern continues, how many elk will there be after 10 years? So one of the great reasons we find this growth rate is so we can create a model. Again, my A value, my starting amount in this case is 30. I started with 30 elk at time 0. And every year it's increasing by a factor of 1.9 to the x. And just a brief aside, this 1.9 is our 1 plus r. So our r would be 0.9, which if I wanted to convert into a percent, I'd multiply by 100, or move the decimal 2 points to the right to get a growth rate of 90%. So the elk are looking really healthy at this point. So we're looking to figure out how this population grows and how many elk there'll be after 10 years. So I'm going to use my model and replace the exponent with 10. Again, remembering to do the exponent part first, unless you have a calculator that can do it all in one step. I'm going to do 1.9 raised to the 10th power. Times my starting amount, which is 30. And I find out that there will be 18,393 elk. Now, there's nothing wrong with extending this table (11, 12, 13, and so forth, and continuing your constant multiplier by 1.9. Well, that can be very tedious. As you see with the next part, we want to know how many elk will there be after 15 years. So now essentially I am tripling the table because I had through 5 and now I need through 15. A lot of math, a lot more chance to make a mistake. Whereas if we have this formula created, all we're really changing is the exponent. So after 15 years, I have the same base model. My exponent is now 15 because that is the time in which we are looking at their growth. So I'm going to do 1.9 to the 15th power times my original amount, which was 30. And I find out that in an additional 5 years, my elk population is going to be 455,433 elk. So we always want to be conscious of what we're measuring, as certain things can be fractionalized, such as money to 2 decimal places, while others, such as populations of people and animals, will not be. I hope this was helpful for you. We're going to ask you to complete the couple problems that are on the accompanying worksheets and then fill out the exit ticket so we can get a little bit of feedback as to how you are doing with this exponential lesson ahead of your upcoming assessment. Take care.